In this video, let's create a method to check a natural number, whether a natural number is prime number or not. Let's get started. So, new Java project. Project name, prime checker. Okay, prime checker, yes, next. Finish. So here we are. We'll create our package. New package. Golden, oh sorry. Golden dot golden letter dot prime. Okay. Finish. And let's create a new. Today we only need a single class, like prime checker, and yes, we need the entry point method name. So this is a static method. So let's create another static method. Private static. This one will answer the question if our natural number is prime or not. So it returns Boolean is prime. Okay, so an int candidate, right? So yeah, we'll introduce if structure of Java program. So we can say if candidate if it's 1, so we know 1 is not a prime number, right? So we can return false. Here, we'll add our code later, and let's return something. This is temporary code. Okay, let's return true. So now let's give it a try. So we can print out SYSO, control space, print out is prime. Let's try 1 here. And command shift F1 to run it. False, right? That's correct. 1 is not. Let's make a copy of that. Command option down key. Yeah. So based on our logic, 2 will be true, right? Anything else except 1 will be true. And right? So false and true. Okay, that's all. Let's also print out the. It's fine. So now we know that if it's like that, if a condition, then if this is true, it will run the code in this block. Okay. Now, what's the logic? Let's implement a very naive algorithm. So let's check 2 also. So, for example, else if candidate equal. We use equal for comparison because a single equal sign will be used for assignment, right? So if it's 2, it's also for, oh, sorry. 2 is our first prime. Okay. Now, our general solution, naive solution, is we'll check one by one. We'll use a for loop here, like int start from 2, and we'll check until the number less than candidate. And so it means if we want to check 10, we'll use 2 to divide 10, and 3 and 4. We'll use each of the number from 2 to the one less than candidate to divide the candidate, right? To see if the I divides the candidate evenly, right? If yes, we know it's not a prime, because a prime can only be divided evenly by 1 and itself. So in this case, we can return false, right? If candidate, this is the modulo operator. It means the remainder of the division divided by I. If there's the remainder is 0, it means it. Let's move this into that. We can return false. Otherwise, you will keep trying 2, 3, 4 until the last one. If no one can divide, right, candidate evenly, then you will, the execution of the program will arrive here. It will return true. Let's try something, and let's try 3. Three, 4, 5, 6. This is stupid. Okay, but anyway, let's run it. After that, we'll improve that using our for loop. So 1 is false, 2 is okay, 3, 4, yeah, 4 is not, 5, yes, 6 is yes, good. So let's put it inside our for loop. For and t I equals start from, we'll start from 1 I, that's length, say let's check 10 of them, 1 to 9, yeah. So I and now we can move in this one and delete all of them and put I here. So we'll check through 1 to 9 to see each one is prime or not. Run it. 1, 2, 3, 4, 5, 6, 7, yes, 8, 9, cool. But today we'll try to test some interesting numbers. Get ready? The first one is 31. 331. 3,000. Okay. Let's try those three first. And let's comment out this one. So let's run it. Let's check those three numbers. Wow, all of them are true. So does it mean this is a pattern? To get prime number. Now 33,331. Another one. Okay. Did we just find the pattern for generating prime numbers? Let's see. Okay. So other one and another one. Let's say it again, right? This method is not efficient enough. It's a naive implementation of prime number checking. Run it. So it's slow. Wow. Let's add another one. What is this? So, oh my God, this is million. Wow, it's almost trillion. Let's see if it still holds true again. Oh, another one. So, oh, it's beyond. I guess it's beyond the range. Okay, so we need to use a long data type. Can we do that? Yeah, you see the initial. What's the problem here? Out of range. Okay, so let's do this. Put a long here. But now we need to change this to long. Okay, so it means the data type will be double the length, I guess, of the int. So let's give a try. What? False. Maybe let's try again. Oh, sorry about it. So it means in our previous running, so I didn't wait until it finishes. So actually this is already, okay, let's put it back here. Let's double check. Come now this one. So this is inside the range of int because it takes a while to stop, okay? Or we can just comment out the other thing and focus on this one only to make sure. This should be false. And it takes a few seconds, I guess. Run it. Oh, it's fast this time. Now let's uncomment this one. Save. Run again. So that it means, oh yeah, it stops here. So it's not the pattern for prime numbers. It stops here. And okay, so actually it doesn't make too much sense, right, to check the other one. But anyway, if we want to check this one, we need to use long here. And so the last two will be false. Yeah. So since it already stopped here, we can delete that and put back in here to keep our example simple. And since we already have the for loop here and if, yeah, like I mentioned in the previous video, right? There are three important things in programming. One is all the programs, right? At least in Java, the code run in order. Like it will run this first and this the second, one by one, right? In order. The second structure, the second important thing is the if structure. And the third one is the for loop, automatically to check, to repeat the task inside its body. If is for branching. So we already touched all the three important things in programming. Anything else you can think about is the organization thing. It's like that we can create a new function or method, right? We can also put those code directly here, but creating a new method make our life easier. So we don't need to duplicate that for each number we checked. Yeah. So let's clean up that, delete that. Let's run one more time to make sure our sample code works. Yeah, the program checks this very fast. And for the last one, because the number of iterations right here is getting bigger and bigger, so it takes like about 1 second for this result to pop up. Okay, so that's it for today. See you next time.